Okay, I wanted to apologize because in the last video I implied at least that my shape was the subclass of shape 2, and I shouldn't have said that. They are, well, they're related but not in a they're kind of they're kind of synchronous with each other. They're related to each other, but it's not like this is a subclass of this. This is the my shape, and again, we'll call this one shape 2, and I'm just giving you the name of the classes. One is not necessarily a subclass of the other. In this particular case, the way these are divided, you might also you can just call this the work class, if you will, because it's the class that's doing all the work. And this is like the run class. Let me just type out, or let me write run on here. So there is a symmetrical relationship, or slightly asymmetrical, but there's a relationship between them. There's a reliance with them, because actually the main class, once you, even before you instantiate my shape, we'll be able to visibly see the shapes created a variable right here. And once you instantiate it in with the new keyword main, the object you create in main will be able to see shape, height, and base. And let's go ahead and try it out with the dot operator. And in case you're seeing, this is where I was able to generate, though this is how I was able to generate the diagram here. Okay, it was in IntelliJ. That being said, let me move this down. Let me bring this. So with once we actually instantiate my shape, and we're using my triangle as a variable, actually, let's do this. Let's create something new. Let's just say var a equals new shape. And now if we do a dot, we have access to height, calc, triangle method. These are just methods that are coming from the object class. Okay, and we do have visibility with height. Okay, and even so, even after, even prior to us instantiating it, if we just do my shape dot, we also have access to base shapes created and the shape name right here. So in other words, there's all kinds of reliance and dependence. I'm trying to get to my PowerPoint. Here it is. So there is all kinds of reliance and dependence on main and mine shape. Excuse me, on the main class, which is shape 2, and the my shape class. Okay, there's all kinds of dependence between each other. Let's reduce that dependence. So right now, there is 1, 2, 3, 4, 5, let's say 5 degrees of dependence between these two. Because here, let's say we change height to something else. Let's say in my shape, let's say height is not height. Let's say we just do height. Double height is just, let's spell out height like this. And what happens here? All this becomes a problem. Okay, height, all that. Right now it's almost like a misspell. It doesn't know because we simply changed the variable called height right here. It doesn't know. So in other words, because main was reliant on height, if we change height, it also messes this up. So there's a reliance that main has to my shape of a degree of 5. Okay? Now let's change that with the private keyword. Let's go back here. So let's say, for example, let me just change this back to height so I don't have all of these horrible red marks. So let's make it so that we can't get to shapes created before we instantiate it or at all. So let's go to shape 2, the shape 2 class, the main class. Okay, and we can see here that if we do, for example, my shape dot, we do have access to shapes created. So we can say shapes created equals, let's say we want it to start at 0. So when we go ahead and compile it, it does compile, although you can't see it. Let's make it so that we can't get to this, because honestly, we wouldn't want somebody to come around and say shapes created equals 100. Okay, let's say that is too much. We want to prevent that. So let's say that let's just be fair. We'll keep this as shapes created equals 0. Okay, so we can go ahead and run that, and it does give us a more fair aspect here. And then of course let's make sure we don't overwrite it right here. So let's run it again. Okay, so now shapes created does start at 1. You can see on the very bottom here the pattern is correct. So let's make it so we can't even get to shapes created. Let's prefix it with the private command, a private keyword. And now let's do my shape dot, and we can see that we no longer have access to the amount of shapes created. Okay, now if we did say shapes created equals 1, we can say that's an issue, because shapes created is affixed with the private keyword. Now if we go back to our PowerPoint right here, what this means is we reduced the amount of access that main has by 1. So now the degree of dependence that main has on shape is now 4, because we've made it so that it no longer has access to shapes created. Okay, let's say we wanted to make sure that we never change the name of shape. Let's go back to our program right here, and let's say string shape is triangle. Now if we go back to here, my shape dot, and we can say that we do have access to shape name right there. But let's make it so that we have private sorry about that. We have static private string shape. Okay. Now let's do my shape dot, and we can see we no longer have access to string shape. Okay, because of the private keyword. So if you go back to our PowerPoint here, we've reduced the dependence that main has on my shape we've reduced it from 5, then 4, and now we've brought it down to 3, because we made it so we don't even see the shape. So you can see, you have an idea now of the effect of the private keyword. And another way you can say this is that when we look at this, we can say anything with the private designation to it has been abstracted from outside classes. Okay, so we've abstracted shapes created, and we've abstracted shape. So that is abstraction in a nutshell.